Hey guys, welcome to the video. Today we're going to be doing Mathematics 0580, variant 23 of the May June series from 2015. So let's get started. Today the problem faced by us is question number 19. Okay, so let me tell you two concepts that will be used by this question. This question is about vectors and it will use two main concepts. One is the concept of general vectors and the other is the concept of position vectors. So let's just get started. I'll explain position vectors later on in the video when we get to part 2. However, for now, we're just going to stick with general vectors. So question number 19 states, OAPB is a parallelogram. O is the origin. We need to remember this for later on. O is the origin. OA is equals to A and OB is equals to B. M is the midpoint of BP, meaning of the line BP, M is half of it, meaning from B to M and M to P, it is the same vector. So, the first question, part A, says find in terms of A and B, giving your answer in its simplest form. So, B to A would be from here to here, so we need to reach from B to A. So, first of all, we would do B to P, vector of B to P plus the vector of P to A. B to P is okay. Now, over here we use the concept of parallelograms. See, over here we have O to A, which is A. However, we also have B to P. B, as this is a parallelogram, OA and BP both are parallel. When lines are parallel, they have the same vector. So B to P will also be A. And lines OB and AP are also the same parallel lines. So we will also have their vectors as the same. So now we know B to P, which is A, plus P to A, which is B. But as we can see, we're going in the opposite direction, so the vector will become negative. So I will just write that in our brackets. So the answer can be written as A minus B, but you have to underline both A and B. And then you can only receive 1 mark, unless you will not receive even 1 mark. So you can also write it as minus B plus A, but the general term to write it as is A minus B. The position vector of OM. Now I'm going to introduce you to the concept of position vectors. So a position vector is a vector from the origin to another point. For example, the origin over here is O. So any point such as OM, OX, OB, OA, and OP, all of these are position vectors, as O, the origin, is present in all of them, and they're going to point M, point X, point B, point A, and point P. So these are position vectors, or PVs for short. And over here, keep in mind that in this question they're asking us for the position vector of M, so this one. So we're finding OM, vector OM. So first to find OM, we're going to have to find O to B plus B to M. O to B will be B and B to M will be positive half A. The reason we're taking half A is because over here we have A as its value, or as its vector. So B to P is a line. Think of it this way. It's a line with the value 100. And M over here, they've told us that M is the midpoint of BP. So meaning M is at exactly 50. So BP is divided as 50 ratio 50, which is 1:1. So from B to M is the same distance or the same vector as from M to P. So we will just write this as the answer. This is our answer, 1/2A. You have to underline them or you will not receive even 1 mark. X is on BA. so that bx is equals to xa. So x is this point. So they're telling us that bx is 1 and xa is 2. So the line b to a is in total 3. So the ratio is 1:2. Show that x lies on OM. So we're trying to prove that x lies on this line right here somewhere. It lies on this line. So for this to be true, we're going to need one of the vectors to be a scalar product of the other vectors. This means that, for example, let's take two vectors such as OA and OB. So the scalar product of one and the other is, for example, if we multiply OA by 1/3, then we get OB. And if we divide OB by 1/3, then we get OA. So this means scalar product. Scalar product is basically multiplying by a scalar digit, this or this or this. It can be any digit. So over here we have to make the relation between O to X and O to M. Then only we can prove that if they're collinear or if they're on a straight line. So first of all, we need to find the value of O to X. O to X will be B, as O to B is B, plus B to X, which will be 1/3 1/3A minus 1/3B. The reason it is 1/3 is because B to A is 3. So from B to X is 1/3. So, and then because it's 1/3 of B to A, and B to A we found over here is A minus B. So we'll just write it like that. Is equals to OM, which is going to be from which is the position vector of M, the one we found in the previous part. So that will be B plus 1/2A. Let's just underline them. So now we can see that OX is just 2/3 of OM. So we can write it as 2/3 OM is equals to OX. So because both of these vectors are scalar product of each other, this is true and you will get 4 marks for this. Bye guys, hope you enjoyed the video, and if you like more content like this, then please subscribe. I'm a new channel, I'm just starting right now, and I would love the support, and see you some other day, I guess. Bye.